In this video, we're going to go back and revisit our exponential growth and decay applications. However, now we're going to be able to solve them backwards for different variables because of knowing how to solve exponential equations and logarithmic equations. I have reminded you here on the formulas for exponential growth and exponential decay, just in case you need those. Number one, let's go ahead and start the problems. It says Mark started a new blog to write about his travels, and in its initial week, the blog had 800 readers. From that point on, the number of readers each week increased by 25%. Use an exponential growth model to find the weeks in which it takes the visitors to reach 10,000 people. So first off, let's write our function f of t. We start with 800 readers, and we're growing at a rate of 25%, which is again 0.25 is your r. So therefore, since it's growth of 0.25, that's going to be 1 plus 0.25 here to the t power. We want to know how many weeks. So we haven't done this yet. We're looking for our t value. How many weeks would it take to reach 10,000 people? So when will the number of people equal 10,000? So let's go ahead and take out our f of t, and let's replace it with 10,000 followers. And we're going to have to solve this equation. The way we solve it, again, we have an exponential equation. Let's isolate our exponential by getting rid of 800 by dividing by 800. Now, what I would like to do here is reduce this, divide top and bottom by 100, gives me 100 over 8. And you could even reduce that even further. 100 divided by 8, that's going to give you 12.5 equals 1.25 to the t power. Now, a reminder, solve this. Now, here's what's tricky. You are used to seeing the 12.5 on the other side. And sometimes it confuses people when it's on that left side. So if you need to, you can write it on the other side. Now, an exponential equation, now you simply have to change forms. That'd be the log base 125 of 12.5 is equal to t. We're going to type that into our calculator by doing the log of 12.5 divided by the log of 1.25 is equal to t. Type that in, and you're going to get a value of about 11.3. Now, let's go back and make sure we answer this problem correctly. Notice it says find the week. So that would be after 11 weeks, he's still not there because it's going to take a little bit more than 11 weeks. So it's going to be week 12 is when he finally sees that mark. Okay, number two, a new stock entered the stock market in January 2012 at 72 cents per share. 4 years later, the price of the share was $3.85. Using a continuous, now remember continuous, anytime we see that, we're dealing with APERT. A equals PE to the RT power. So using APERT, find the growth rate. We're looking for the R value here. So we started, let's see, let me write down our formula. A equals PE to the RT power. We started at 72 cents a share, so the P value would be 72, and we grew to $3.85 a share. So there's your growth. Started at 72, grew to that. The E is a constant, 2.71828. We're looking for the R value. The T value is the 4 years that it took. So R times 4 up here we can write as 4R. Now we just got to solve it, and that's going to tell us what our rate is. Step number one, let's divide by our 0.72. And you can divide that out. You're going to get about 5.3472, and that's equal to e to the 4r. Now we've isolated. You isolate your exponential. Next step, you rewrite it. And again, you're used to seeing the 5.3472 on the other side. So if you need to move it over there to rewrite it to make it easier, you're going to do the log base e, which is ln, of the value on the other side. Ln of 5.3472 is equal to the exponent. So therefore, you can get rid of the 4 by doing 1/4. You can divide by 4, or you can take a fourth of it. And again, the reason I write it as 1/4 is because that could actually be written as an exponent. You can move it up front. Whichever way you do it, the rate is going to be about 0.4191. And since it is a rate, let's write that as 41.91%. That's a large growth rate there. Number three, a certain medicine has a half-life of 5 hours. And again, half-life is the amount of time it takes for that medicine to lose half of its volume or lose half of itself. The patient is given 500 milligrams at noon At what time will they have 100 milligrams remaining in their bloodstream? Since we're dealing with half-life, again, the rate of decline, the rate that you lose it is 50%. Now, the half-life is 5 hours. This is a lot like a problem that we worked in our exponential growth and decay section. So you can go back and revisit it if you need some help with how to set this up. If it's exponential decay, or excuse me, if it's a decay problem, it's exponential decay. We're starting with a 500 milligram dose. So our function looks like this: f of t equals 500. 1 minus the 0.50 is going to give us 0.50. And since the half-life is not 1 hour, it's 5 hours, you're going to do t divided by 5 as an exponent. Again, go back and revisit that problem if you have questions about why we did that. When will they remain? When will they have 100 milligrams remaining? So what we're going to do, we start with 500. We want to know when is our y value, when is the amount left equal to 100. So what we're going to do to solve this, first step, isolate your exponential by dividing. So we have 100 over 500, which is 1/5, which is 0.2, is equal to 0.5 to the t over 5 power. Once you do that, we're going to change forms. That's going to change into log. And again, you can put the 0.2 on the other side if this is confusing. Log of base 0.5 of 0.2 is equal to the exponent. And you could go ahead and multiply that by 5 if you'd like to, get it over here. You could raise that to an exponent if you'd like. But we're going to rewrite it as 5 times the log of the 0.2 divided by the log of the 0.5. I simply used my change of base formula, type that in, and you're going to get about 11.6 hours. Now let's go back and again, look at your problem. At what time? So we've got to do 11.6 hours. We've got to figure out what time that'll be. And you've got to be careful since we're looking for what time. Now this goes back, this is might be some old math that you might have seen before. 0.6 of an hour. So that'd be 11 hours, 11 full hours. But what do we mean by 0.6 hours? 0.6 of an hour. Now an hour is 60 minutes. So to change that 0.6 to minutes, we've got to do 0.6 of 60 minutes. The way that you find of in math, a fraction of, is you multiply. 0.6 of 60 minutes would actually be 36 minutes. So that 0.6 hours is 36 minutes. So 500 milligrams was at noon. So 11 hours and 36 minutes later, that's when we're going to have 100 milligrams remaining. So that'd be at 11:36 p.m. Okay, number 4. We have a logistic problem, and a logistic, if you remember correctly, it's exponential and then levels off. So it looks something like that. And this right here is where it levels off. That's going to be your extreme value. You're going to have a horizontal asymptote at that 250. So let's try to work this. The growth of a plant can be modeled by the equation below, where h is the height of the plant. And obviously we see that the plant will not get over 250 centimeters. T is the number of weeks since the seed was planted. How many weeks will it take the plant to reach a height of 50? So we're simply solving this. We're setting it equal to 50, and we're going to solve it. First step is let's get rid of this denominator by multiplying. So we now have 250 is equal to 50 times the denominator, which is 1 plus 12 times e to the negative 0.72t. Now, you're going to be really tempted to go ahead and distribute that 50, but it's going to be much easier to go ahead, instead of distributing, since it's being multiplied, let's move it over here and divide. And then you have 5 equals that denominator, and that looks a little bit better. 12e to the negative 0.72t. Let's move our 1 over by subtracting. You then have 4. Move your 12 over by dividing. So you have e to the negative 0.72t is equal to 4/12 or a third. Now we can solve this thing. We've isolated our exponential. So next up, let's rewrite it. That'd be log base e of the 1/3 is equal to the exponent, which is negative 0.72t. Let's go ahead and get rid of the negative 0.72 by dividing by negative 0.72. So now this is all just typing into our calculator. Use your natural log button, the natural log of 1/3, divide that by negative 0.72, and you're going to get about 1.53 weeks. So it's going to take 2 full weeks. It's about a week and a half. It's going to take nearly 2 full weeks in order to get that height that we need. Number 5, another logistics problem. A small lake is stocked with a certain species of fish. The population is modeled by the equation below. P is the number of fish in thousands. So again, that's the maximum. We're never going to get over 8,000 fish here. And T is the number of years since the lake was stocked. How many years will it take the fish population to reach 6,000? So we want to know, when is the population going to reach 6,000? Be careful, because P is the number of fish in thousands. So we're wanting to know, when's it going to reach 6? Because again, P is in thousands, so we're wanting to know 6,000. Get rid of the bottom by multiplying. So that's going to be 1 plus 3e to the negative 0.7t. Is equal to 8. Then let's get rid of the 6 by dividing by it. So we're going to have 1 plus 3e to the negative 0.7t equals 8 over 6 over here can reduce to 4/3. That would be 3e. Let's get rid of the 1 by subtracting. 3e to the negative 0.7t equals, subtract 1, which is 3/3, and you're going to be left with 1/3. Let's get rid of the 3 by dividing, which is the same thing as multiplying by the reciprocal. And that's going to turn this into a, let me zoom in just a little bit, a 1/9. And now we can change forms. This would be log base e of 1/9 is equal to negative 0.7t. Cross out the negative 0.7 by dividing, since it's being multiplied, and you're going to get, here would be the exact answer. Now, if you want to change that, you could write this as 0.7 to be 7/10. You could flip and multiply by that, and that would be 10/7. You could do all sorts of negative 10/7, all sorts of stuff there to simplify this over here. But the main thing is our answer here. T is going to be about 3.14. T is about pi years. So let's go back and look and make sure we answered. How many years will it take the fish population to reach 6,000? By that 3rd year, it's not hit 6,000. It'll take a little over 3 years. Next problem. We're compounding interest. Okay, let's talk about our formulas. Just to remind you of those real quick. A equals P times 1 plus R over N to the NT power. That was when our interest was compounded monthly, daily, quarterly, or semi-annually. However, we did have a formula also if it was compounded continuous. We use that APERT formula again. So number 6, it says $500 deposited, annual interest rate of 4%, compounded quarterly, so that means that our end value would be 4. Let's go ahead and write the other ones. Our initial investment, our principal was $500. Our interest rate is 4%, so that'd be 0.04. We want to know how long. So we're looking for time. So time equals question mark. How long will it take the amount of money that we have to reach $1,200? So let's plug everything that we have into our formula. And there you go. And let me zoom in a little bit. Now, step number 1, always isolate your exponential. Now, this is a little bit different. Here is your exponential. All that stuff being raised to the 4t power. So let's move our 500 over here, since it's being multiplied, divide by it. And that'd be 12/5. You could actually reduce that down. The 1 plus 0.04 divided by 4, you can divide this. That's 0.01. So you're now going to have 12/5 equals 1.01 raised to the 4t power. And you can change this to a decimal. That's going to be 2.4 if you would like to. So there's your equation. Now let's change forms. That would be log. And again, you can move the 2.4 over here if you need to make it look like the ones you've been looking at. Log base 1.01 of 2.4 is equal to 4t. You can, to type this into your calculator, that'd be log of 2.4 divided by the log of 1.01. To get rid of the 4, you can take a fourth of that, which is to multiply that by 1/4. That actually puts the 4 on the bottom, is equal to t. Type that into your calculator, and you're going to get about 22.00 years. Is nearly exactly 22 years. And let's make sure we answer the question correctly. No other deposits. Yes, how long will it take the account to reach that balance? Number 7. Dave deposited $500 in a savings account. After 15 years, the account balance has tripled with no other deposits or withdrawals, assuming the interest rate compounds continuously. As soon as you see continuously, we know that this is an APERP problem. He invested 500, and we want to know after 15 years, it tripled. What is the interest rate? Now, let me show you a trick on these. Honestly, it doesn't matter that they gave you the amount of money he invested, because let's write this down. He invested 500, and we want to know how long it's going to take, or it took, what the rate was that tripled it. So started with 500, so obviously now we have 1,500 because it has tripled. We don't know the rate, but we know that it took 15 years. So R times 15, which you can write as, let me erase that, we can write that as 15R up there. But let me show you this. Step number 1, you're going to divide by 500 anyway, and look what you get. 1,500 divided by 500 gives you 3. Now, what if it was any other values that tripled? What if you would have started with $10 and it now turned into 30? It tripled. Next step, when you divide by 10, you get 3. So it doesn't matter what value you started with. If it's an amount of money that has tripled, this problem is going to be worked the exact same way no matter what. So they could have just said, your money has tripled. And you could have said, well, I started then. Let me zoom in a little bit. We started with an amount of P, and we now have 3P. It tripled. When you divide by P, the P's cancel, and it leaves you with 3. So regardless of the amount of money, it's always going to be worked the same. Now let's change forms. That'd be log base E of 3 is equal to 15R. Last step, divide by 15. So all you have to do is the natural log of 3 divided by 15. That's going to give you an interest rate of about 0.0732. So your interest rate is going to be, we'll call it 7.32%. And the last one, Scarlett invested $8,000 in an account, pays 7.5% interest per year, compounded continuously. So as soon as you see continuous, again, we're dealing with a base of E, an APERP problem. How long will it take the account to reach $10,000? So we started with 8,000. We want to reach 10,000. E to the, let's see, the interest rate was 7.5, so 0.075 times T. Step number 1, we always divide by that 8,000. Reduce that, and you have 10/8, which will be 1.25 equals E to the 0.075 T. Let's change forms. That would be log base E of the stuff on the other side, 1.25, is equal to the exponent. Last step, divide by the exponent, 0.075, and that's 1.25 on top. I kind of lost that decimal. When you divide that out, you're going to get T has a value of about 2.975, and that's in years. So if you want to know how many years will it take, that's going to be right at 3 years.